Your PowerPoint notes titled Air Pressure and Winds introduced you to the characteristics of high and low pressure cells. In anticipation of you having some confusion still about high and low pressure cells, my intention is to provide a bit more information through this mini lecture. You already have access to this list of characteristics of high and low pressure cells, but I want to focus on number 4. Number 4 is important for us to understand with regard to high and low pressure cells, but it's also important for us as we begin to understand how and why it rains. And don't forget that 5-star rule that warm air holds more water vapor than cold air. This simple diagram shows you the capacity of warm air or cool air to hold water vapor. And warm air holds more water vapor than cooler air. With regard to high pressure cells, they are associated with descending, sinking air that starts off cool and then becomes warmer as it gets closer to Earth's surface. Highs are formed over cooler surfaces. Cool surfaces cool the air above, and cold air is heavy and dense, which forces it to sink. Low pressure cells are associated with ascending, rising air that begins warm, and as it rises and ascends and gets further away from Earth's surface, it gets progressively colder. Low pressure cells form over warm surfaces. Warm surfaces, warm land, warm water. It heats the air directly above it. Heated air is more buoyant and always rises and ascends. As it rises and ascends and gets further away from Earth's surface, it gets progressively colder. Okay, I want to spend a few minutes helping us better understand high pressure cells and low pressure cells. But before we wrap this up, let's make sure that we remember that 5-star rule. And that rule is warm air holds more water vapor than cold air. Don't I have more space to hold on to water vapor here versus here? So cold air holds less water vapor than warm air. For this example, let's use a small sponge, the kind that you might find next to your kitchen sink. We'll use this to be our cold air. And we'll use the big sponge you might use to wash your car as warm air. Warm air holds more water vapor than cold air. So with regard to pressure cells, high pressure, which is associated with dry conditions, high pressure cells are associated with descending, sinking air. So it's starting off cold. Isn't it colder up in the higher altitudes than it is down here? So it starts off cold and it descends and it sinks and it gets warmer. So it's starting off as the smaller sponge and becomes the larger sponge. Warmer air holds more water vapor. So let's take just a half a cup of water and imagine I'm pouring it slowly into this sponge. This sponge could hold on to that half a cup of water. But in this example, the air is descending and sinking. It is becoming warmer air. Warm air holds more water vapor than cold air, and this warm air is going to have no trouble holding on to this much water vapor. Hence, high pressure cells, you have dry conditions. Now compare that with low pressure cells. Low pressure cells are associated with ascending, rising air that is cooling. Cold air holds less water vapor than warm air, so guess what? It could possibly rain. So in this example, we're going from the warm air up to the cold air. Imagine taking a whole pint glass of water, pouring it into this sponge slowly. The sponge is going to be able to handle this much water or water vapor. It's not going to leak. But with low pressure cells, the air is ascending and rising. It is cooling. It's becoming that smaller sponge. Is this sponge going to be able to hold on to this much water vapor? Absolutely not. We will saturate that sponge, and once it is saturated, it's going to be leaking down my hands, and hence it will be raining. So again, low pressure cells are associated with wet conditions, and high pressure cells are associated with dry conditions. Let's test our understanding of high pressure cells and low pressure cells and where we would find these on Earth's surface. One of the problems that we in Southern California have is our understanding of weather. We have a distorted version of weather because we think of warm conditions like summer, we think of that as dry, and we think of cold conditions like winter, we think of that as our wet season. But just so you know, we're weirdos. Everywhere else on the planet has their wet season during the summer. So maybe some of you have friends or family that live in Arizona. When is their rainy season? Have you ever heard them talk about Arizona monsoons? When do those monsoons arrive? It's always July, August, September, and dang it, those storms, those big, huge rainstorms, what time of day do they show up? 3 o'clock in the afternoon. So their rainiest time is when? At the hottest month of the year, at the hottest time of the year. Why? Because that blazing heat does what to those surfaces? Heats the surface, and that heated surface heats the air directly above it. And now that heated air is always going to do what? Rise and ascend and cool. Cold air holds less water vapor than warm air, hence it can rain. So let's see if we can make this clear while also having our distorted version of weather because we live in Southern California. So what do you think that we have at the equator? Do you think that we have high pressure or low pressure here? A lot of times people want to say that we have high pressure, but lows are associated with rainy conditions, right? And what do we have at the equator? Let's see, the biggest rainforest on the planet, the Amazon rainforest, hence it gets a lot of rain. Indonesia, the next largest rainforest on the planet, what do we have there? Rain. So at the equator, it is associated with low pressure. Why is there low pressure there? Because there are warm surfaces, and warm surfaces, what do? They heat the air directly above it, and heated air always does what? Heated air rises and ascends, and it cools. Cold air holds less water vapor than warm air. Okay, here's another example. What do you think that we have at the poles? Highs or lows? Don't be a Californian in this, because a lot of times what we're gonna think is, oh, it's cold, there's snow, there must be low pressure. No. When you're looking at the poles and you're looking at these icebergs, you're not looking at snow. You're looking at big, huge ice cubes. glaciers that were formed 2 to 3 million years ago and have been melting for the last 10,000 years. So these cold surfaces, these glaciers, what do? They create high pressure because cold air is going to do what to the air directly above it? It's going to cool it. And cold air does what? It's heavy, it sinks, it descends, and descending, sinking air is going to suppress precipitation. So at the equator, we have low pressure cells, rainy conditions. At the poles, we have high pressure cells, dry conditions. Let's talk about what we have in California. Is California dominated by, typically, normally, every single day, are we dominated by high pressure cells or low pressure cells? Dry conditions, right? So we're dominated by high pressure. Now, I said that California can be a confusing example because the bulk of the world, they have their wet season during the summer, and we're the oddballs that have a dry season in the summer and a wet season in the winter. So while this can be confusing, what example could we use where we're using California as an example? Well, let's compare Florida with California. If you've been to Florida, you know that the water there is very warm. It's so warm, it's like a bathtub. It almost doesn't even cool you off. If I go scuba diving there, I do in the Caribbean or around Florida, I don't need a wetsuit. It is so warm, you don't need a wetsuit. I can be down for 45 minutes and I'm gonna be just fine. It's really warm water. Well, when you think of Florida, do you think of it as more rainy conditions or more dry conditions? If it's more rainy, which it is, it has to be dominated by low pressure. Why is Florida dominated by low pressure? Because it has warm water. That warm water, you're starting to get the picture here, heats the air directly above it. Heated air always does what? Rises and ascends, cools. Cold air holds less water vapor than warm air, and so in Florida, it's going to rain. Now compare that with California. What's our water temperature like? Super duper freezing cold, right? If I go scuba diving out in Catalina, I'm gonna jump in with a wetsuit, a very thick wetsuit. I'm gonna have gloves on, I'm gonna have booties on, I'm gonna have a hoodie on to make sure that I am as warm as possible in our very, very cold water. I'm gonna jump in there and 25, 30 minutes later, I'm gonna say, get me out of here and get me some hot cocoa on the boat because it's so dang cold. So our cold water does what to the air directly above it? Cools it. Cold air descends, it sinks, it's heavy, and as it descends and sinks, it's going to suppress precipitation. So if you're looking for an example of how to use California to help your understanding, compare California with Florida. Our cold water creates high pressure and dry conditions. Florida, am I pointing to Florida? Florida has warm water. That warm water creates low pressure and they have rainy conditions. We're rolling. Everything looks clean. That really bugs me. Push stop.